The topic is finding the range of function. So we'll explore three methods to find the range of the function. So first method is shown right now. First method is a conventional method. Second method is an inverse method. And the third method is a graphical method. So in the first method, so what we do is first we find out the domain of the function. So let the domain is a closed interval a comma b. So for the given function y equal to f of x, we find the values of x for which the derivative is 0. That is, we find the critical points. So what we do is first we find the derivative of the function and equate it to 0 and find those values of x. And critical points are also the points where the first derivative is not defined. So we find those points also. So now the range would be the maximum or minimum of the set f of p and f of a, the lower limit, and f of b, the upper limit. So the minimum of this would be the lower range and the maximum of this would be the upper range. So this is the case if it is in the closed bracket. If the domain is in open brackets, so if the function domain is from open interval a comma b, so similarly you have to do the same, but instead of finding the direct values, so what you do is you find the limits of the function at x tends to a and x tends to b, and to find the range you find the minimum and maximum of these points. So now let us see the first method. The given function is x square plus 5 by x square plus 4 equal to y. So first what I am doing is I'll find the domain of the function. So because the denominator is defined always, so there are no points of x for which the denominator is 0. So the domain of the function is y equals to r. So the domain is all x. Now I'll find the first derivative of the function. First derivative is obtained as u by v rule. So u dash v minus v dash u by v square. So simplifying that, I get minus 2x by x square plus 4 whole square. So I want to find the points for which the first derivative is 0 and the points for which first derivative is not defined. So those are the points which are called as critical points. So equating the first derivative to 0, I get at x equal to 0 the function first derivative is 0 and there are no points of x for which the function is undefined. So substituting the value of x equal to 0 in the function, I get f of 0 is 5 by 4. Because the domain of the function is all values of x, there are no critical point. There are no points where the function is not undefined. So I'll find the limits of the function at x tends to infinity and x tends to minus infinity. So as x tends to infinity, the limit of the function tends to 1. You can substitute the limit in the given function and check it. And as x tends to minus infinity, again it will be plus 1. So how do you check it is, you take x square common from the numerator and denominator. So it would be 1 plus 5 by x square by 1 plus 4 by x square. As you substitute x tends to plus or minus infinity, so that term by x square would tend to 0 and you will remain with 1. So that's how you get the limit at x equal to infinity and x tends to minus infinity. So both the limits x tends to infinity and x tends to minus infinity are 1. So now, and f of 0, the critical point, the value is 5 by 4. So to get the maximum range of the function, so that would be the maximum of this x tends to infinity and f of 0, so which is 1, and the minimum range would be the minimum of this x tends to minus infinity and f of 0, so which would be 5 by 4. So now the range is the open interval of 1 comma 5 by 4 closed, because the 1 is obtained from x equal to minus infinity. Since minus infinity is not in the domain, it is not included, so that's why we kept it open, and we got 5 by 4 from the critical point. So this is the range of the function. So this is the first method. Now the second method is using inverse. So if the function y equal to f of x is given, so the domain of the function is the inverse of the function. So domain x can be obtained as the inverse of the function y. So domain of f inverse of y is the range of f of x. Just pause the video and try to understand this. So let me explain this. So the function y, the values which the function takes are y, and this is the range, and the values that are input is the domain. So if I take the inverse of this on both sides, so domain x is equal to f inverse of y. So domain x equal to f inverse of y. So now this is the input to the function f inverse. So that means y is the domain of f inverse, which is the equal to x. That means the range of f of x is the range of f inverse of y is x, which is the domain of actual function, and the domain of f inverse y is the range of f of x. So just by finding the domain of f inverse y, we can find the range of the function f of x. So this step is very important. This inverse method can be applied to find the range when there are no points of x for which the function is not defined. Since we have seen the domain of the function is all values of x, all values on the real axis, so there are no points for which the function is not defined. So then only we can apply this inverse method. So now what I do is I multiply this denominator in this point, and I try to subject x as one side and y on the other side. So by simplifying this, I get x equal to plus minus under root of 4 y minus 5 by 1 minus y. So I know the domain of the function is x, actual function. The domain of the actual function is x, and it is all r. So x belongs to all r, and which is having under root. So for this function to be valid, the value inside the square root should be positive. So 4 by minus 5 by 1 minus 5 should be greater than 0 or equal to 0. So if so for solving the inequality and taking the wavy curve, so at y equal to 1 it is not defined, at y equal to 5 by 4 it is 0. So all the points which are greater than 5 by 4, it is negative, and for all the values of y for which it is less than 1 are again negative. So these are the points in between 1 and 5 by 4 for which this function is greater than 0, and 1 is not included as it is undefined. So that would be, so we'll be getting the from the wavy curve y is belonging to the interval 1 less than y less than or equal to 5 by 4. So this is the same range we got in the previous method. So now the third method is by using graphs. So we have seen the domain of the function f of x is r, and as you can see, both the numerator and denominator are always positive. So y is always positive. So first let me find the first derivative of the function. So first derivative will be minus 2x by x square plus 4 whole square. So first derivative is 0 at x equal to 0, and for all the values of x greater than 0, the first derivative is negative. That means the function decreases for positive x, and the function increases for the negative x. And finding the double derivative of the function, so I would get this minus 2x power 4 minus 32 minus 16x square minus 8x power 4 minus 32x square, and solving this we get the roots as minus 2 and 2. So second derivative is positive between minus 2 and 2, so it is having concave up and minima between minus 2 and 2, and it is negative beyond 2 and to the left of minus 2. So that means it is having concave down on the both sides. So next let us find the limits at x tends to infinity and at x tends to plus infinity. So as x tends to minus infinity, we have already seen that y tends to 1, and x tends to plus infinity also, it tends to 1. So from these points we'll try to plot the curve. We have seen that the domain of the function is all r, so the domain is all r, and f dash is greater than 0 for negative x, so the function is increasing in the negative region of x, and it is decreasing in the positive region of x. And we have seen that the f dash is 0 at x equal to 0, that means it has a critical point here, and the value of the function at f of 0 is 5 by 4, as we can see here. So this would be the graph, and we have seen that as x tends to minus infinity, so the value of the function tends to 1, so that can be seen here, and as x tends to positive infinity, again the value tends to 1. So this is how the curve would look like. So we can clearly see that the range of the function is from open interval 1 to closed interval 5 by 4. So these are the three methods how you can find the range of a function. Thank you.